Hi, I'm Teja. I'm a developer relations engineer at Harness. In this video, we're going to learn about how you could perform container scanning using Harness STO. Before we jump into the whole implementation of the process, let me touch upon what container scanning is. So the container scanning is under the umbrella of SCA, the software composition analysis for container images. It scans your images and their dependencies for known vulnerabilities, and it is not just in the application layer of your image, but it also gets into the OS, base image, any language packs, and brings out the vulnerabilities with associated CVEs or CWEs. And it is best if you have the container scanning configured as a part of your CI. So in Harness STO, the module brings you a wide range of scanners for performing the container scanning. Also, on top of this, the module comes with a set of built-in scanners for containers. If you just wanted to perform the scan irrespective of what tool to choose and their configurations, you can quickly set up the built-in scanner using Anchore or Grype as a matter of choice and perform the scan in just a few clicks. Also, it is important to note that the Docker in Docker background step is required if you're using Docker build or Kubernetes as infrastructure. And if you're using Harness Cloud as an infrastructure, you can totally ignore this. Also, if you don't find the scanner that you generally use, STO comes with a step called Custom Scan, where it allows you to use a huge list of scanners that are supported by Harness. And now, let's get into the implementation. So, what you see on the screen is an existing Harness pipeline. I have a few things configured here. So this pipeline is responsible for doing three things: build, scan, and push. So here is the step that helps me to build the Docker image. And this step is responsible for pushing the image that was built. In between, we'll add a step to perform the container scanning. So before we proceed further, let me walk you through this pipeline. So I've just created a stage. This is a security stage. You can quickly create it by adding a new stage. The one I'm using is a security stage, or you can also use the build stage if you're using Harness CI and use all the STO steps. So here I am inside the security stage, and in the overview you can see I have the clone codebase configured. The codebase I have is configured with my connector, which is GitHub. If you don't have your connector, you can quickly connect to your SEM, and then once you connect it, you should be able to find the connector here, and from there you can choose the repository name and then apply changes. So here I am cloning the code base. Next is the shared path. I have added a shared path /var/run. So this enables all the steps to use the Docker in Docker that we'll be adding soon. And next, I have a few stage variables configured. As you get into the advanced, you can see that I have a few stage variables configured. One is the username of my Docker hub. And then I have a personal access token configured from the secrets and getting it from here. And next, I have a last variable, which is about image tag, which I have just set it to a fixed value, but you can also put it to a runtime input or an expression as well. And now let's get into the execution, and let's also look into these two steps at last and get into the container scanning. Inside the build image, I have a simple shell commands, which will just quickly check for Docker and do the build and set the tag. So these are the two important things that it does. And next, inside the push to registry, it just locks in using my Docker hub username and personal access token from the stage variables. This is being accessed from secrets. And next, this will be pushing the image. So we are pretty good. Let's go ahead. Now configure the container scanner. Click on that and then add step. Go to the containers, and this is where you have all the list of scanners that you can use for performing the container scan. Or you can also get into the built-in scanners and choose the container here. And once you choose that, you have the choice to select two of this, which allows us to use a free version of scanners without any licenses. I'm going to choose Anchore Grype. Next, we need to provide the container images to tell where to pull the container images from. So in my case, it's actually local image built-in stage because I'm building the image locally. Or if you're using Docker compliant V2 API registries, you can choose this or any of the others as shown. And next, you need to provide the image name. In my case, this. I'm actually giving a fixed value. You can also choose it as an expression or a runtime input. So here I am. The moment I add scanner, you should be able to find two things got added. One is Docker in Docker and the scanner. So if you get into the Docker in Docker, you should be able to find a few options. I just configured my container registry, and next the image I'm using is dind from Docker, and it just kept to shell. So you can just quickly apply changes. Since this Docker in Docker is needed for all these three steps, we'll put it in the beginning. So let's keep it here. So it starts by cloning the code base as configured during the stage creation, and then it spins up the Docker in Docker. Next, it goes and builds the image from the Docker file from the repository which is cloned. Once the Docker image is built, we'll start the container scanning using Grype. Next, it will go ahead and push to the registry. We can also put some conditions. If there are any critical or high issues, we can block this pipeline. So we'll get into this now. As you click on that, you should be able to find the options. It starts with naming and description. Next, you have the scan mode, the orchestration and the ingestion. So for orchestration, you configure the step to run a scan and then ingest, normalize, and deduplicate the results. In case of ingestion, you configure the step to read scan results from a data file and then ingest, normalize, and do all of that. We will use orchestration, and next you have scan configurations, which is set to default, but these are predefined configurations that you can use for scanning. And next you have the target configuration. So this is where you set the type of the target. In my case, it's container image as it's already set. Next, you have the option to set the target and the variant. It's best if you can go with auto so that it automatically detects the target name and the variant. If you're going to go with a manual, you need to set the name and the variant. So the name is where the label that you wanted to assign to the target that you are scanning. In case of variant, it's an identifier for the target to scan, such as a tag name in our case. So I'll stick with auto here. Next, you have the configuration for the container image. Here you choose the type of the registry where the image is stored. In our case, we're actually building in the stage itself, so we can choose local image built-in stage. But if your image is actually in container registry, you can choose Docker v2 only if your registries are compliant with Docker v2 API. Choosing this will pull the image from your registry and then perform the scan. But in our case, we'll go with the local image built-in stage. And next, this is where you set the domain. So this is the URL of the artifact that contains the image to scan. But I'm going to skip this here. Next, you set the name of the container image, which is this. Next, you set the tag. Here, I choose to go with a fixed value, but here for the tag, let me do a expression, and from the stage variables, I'm going to pull, so the way you call it as stage.variables, and from there, I'm going to pull the tag. Next is the log level. So this is where you set the minimum severity to which you want to include the logs in your scan. So I can put it to info, and next you put the additional CLI flags that you want to pass to the scanner. In my case, nothing. Next you go for the fail on severity, another interesting feature where this is where you set the severity at which you want to fail the pipeline, where if the scan finds any vulnerability with a specified severity or higher, the pipeline fails. So if you set it to high, if there are any vulnerabilities with high or above, the pipeline will fail. So let me put it nothing for now. I'll change this in a while as we move forward. So for now, let's go ahead and actually apply changes. So here we are pretty much ready to run. So let's go ahead, save this and run. The branch name set to main and run pipeline. After fast forwarding, so here we are with a successful execution. It started with cloning the code base and spinning up the Docker in Docker, which is a background step, keep running. And next you have building the Docker image from the Docker file. Next you have the container scanning and then pushing to the registry. So with a successful execution here, as you get into the Docker registry and you just refresh, you should be able to find it got pushed. So here we are a minute ago, and now let's go back into the security test results from the security test tab. And right up here, you should be able to find all the details of this container scanning. So you have a complete overview of all the issues. And here we are with all the critical issues which are present, high, and all of that. And as you click into a specific issue, you should be able to get into the details where it has a description and all of that, where you can specifically see that the file name easybug.jar file where this issue exists. And then you have all the occurrences and all the other details. Also, if you just get into a little more, maybe probably into this one, you should also be able to find the issues are related to the distribution or the base images, which is a Debian distro. So this is how you get into the complete details of the security scan, and also you have IDA to help you remediate these things. And now let's do something even more interesting. I wanted to actually block this pipeline if there is any critical or high issues. So for now, we didn't do that. We just had to continue all of that. And even there are critical and high issues, we push it to the Docker registry. But now let's go ahead and configure in a way it just gets blocked if there are any high or critical issues. So So the way how you do it is get into the scanner and go to the bottom and say fail on severity, and you can set it to high. So if there are any issues higher above, the step will get failed, the pipeline gets blocked, and it won't be pushing to the registry. So let's save this and quickly run this. After fast forwarding, so here we are with a failure execution this time, and as you get into the details, you should be able to find the message fail on severity set to high and that threshold was reached. So there are issues, as you know, high and critical. So this step got failed and the pipeline got blocked and pushing to the registry did not happen. So this is how you can use Harness STO for performing the container scanning. And to learn more about how to use all the different types of scanners, you can refer to our documentation at developer.harness.io. Thank you.